Boys, I am happy to have you here for this class. Actually, have missed you, boys. Although I am not all that happy based on the last test we took, most of the instruction I gave you people to obey in exam, you forgot it. One of the instruction is always make good use of calculator, even if you have the answer offhand, because some of you still mess up with some of the calculations. Some of the questions that I was expecting uh, good grade from it, I saw that he couldn't even see the day light. Please, next time, please make sure you obey instruction and always pay good attention in class. Ask question when you are being permitted to ask question, and ask good questions. Ask, you can come and meet your teachers and ask questions. It's very, very important so that you can have a better grade. The school administration have made it very, very beautiful that even we are using those classwork that you score higher, something like 8, 9, 10, to pull up your grade. But in the main test, you guys disappointed me. It will look as if that the test, the classwork that I used were actually fake, because it does not correlate with what you people had in your main test. Please, next time, always pay good attention. All the question that was given to you people in your main test was actually what you guys have done in your classwork and the assignments I gave you people. And it was resounded to you people to go back and look into that. Please, always pay good attention. Always pay good attention to your teachers. Today we are going to be looking into gas law, and I have a few things I want you to pick up. My objective for the class is you should be able to state the laws and also perform some calculation involving Boyle's law, Charles law, and general gas law. So when we meet next time on Friday, the video for next on Friday, that is next class, we are going to finish up the other gas law. Whether I have taught your class this gas law or not, please humble yourself. I beg you, humble yourself and listen to this, and also watch this video. Make sure you watch this video up to 3 times before you go for my Google class work. Please, I beg you of that, so that you will have a better understanding and see some areas that you need to practice. And I urge you to pick up a pen now and pick up your notebook and pay good attention and pause and play. Try to see if you can be able to do what is being given to you to do. Please, I beg you of this. Let's start with kinetic molecular theory of gas. I want you to know that what we are actually doing in this kinetic theory of gas is to explain the properties of gases, that is the characteristics of gases based on pressure, temperature, and volume. I normally use PVT to represent it. PVT, where P is the pressure and V is the volume and T is the temperature. Even in chemistry, this PVT is used often. And we can even write it as PV equals to T. We can even write it like that. Or we can even write it PV all over T. But that does not matter for now. When the time comes, you understand what I truly mean there. So, in kinetic theory, what we actually looking at when we say kinetic is motion. Something is moving. So that's what we mean by kinetic. So anytime you hear kinetic, you should put it in your mind that we are discussing about movement or motion. And that energy to which a substance or an object possesses while it is moving, we call it kinetic energy. According to what I have here, I say the energy an object has because of its motion is called kinetic energy. So example of this is a ball rolling down a hill. If a ball is rolling down a hill, we can say it is possessing what we call kinetic energy. I hope you get me on this before I go for the next one. If you do not get me, you need to play this once again. That means that when you are walking to school, you possess a kinetic energy. And for gas molecule, what happens to them is that they are always in motion. You remember that the gas theory of matter, if you were in class when I taught you that, I said that particles of matter are always in constant motion. So gas molecules are also in constant motion. Now let's even look at the gas theory itself. There are three main components of kinetic theory that I picked up here, but in my song I use five. But if you listen to the song that I sang about this kinetic theory of matter, uh, gas molecule are in constant random motion, moving in a straight line with a perfect elastic collision. Actual volume occupied by gases are negligible. The forces, the cohesive forces between them are negligible. And from that is about four I have said. The last one is the temperature. And if you watch the video and play the video alone, why I want you to use the YouTube video is because if you use the YouTube video, it has melody, which I know our head likes sound that is very harmonious. So that is why I will refer you to use that video. So let's look at what we have here. The collision of gases are said to be elastic. This means that it is going to be perfectly elastic. This means that there is no loss in energy and there is no gain in energy when the molecules collide. And secondly, the gas molecule take up no space. Gas can be here, I can still enter that room. Is despite gas fill this place, can still enter that room. In the video, I say actual volume of the gases are negligible. That is actual volume occupied by gases are negligible. That is what I use in that place. That means that the gas volume, we can actually ignore it. So gas molecules are in constant linear random motion, where in that song I started with gas molecule are in constant random motion. That is how I put it up in that song, so that it will resound in your head if you play the song. So if you look at the diagram here, you will notice that there is a sign of zigzag motion where they are hitting one another and hitting the wall of their container. Okay, kinetic theory of matter can kinetic theory of matter basically gas can be used to explain pressure. So I would like to do a little work on this. Gas pressure results from fast moving gas particles colliding with the sides or the wall of a container. You know that gases are being placed inside container. So since they are moving randomly and they don't have sense, they don't have any sense organ, so they move blindly without knowledge. So as they are moving, the possibility of them hitting one another is 100%, not below 100%. It's 100%. So we have assurance that they will hit one another. Now when they hit one another, they are going to change their direction, and when they change their direction, they will hit another, they will keep on hitting another, and as they're hitting another, they are also hitting the wall of their container. Now when something hits a container, the force that is using to hit that particular area, we call it pressure. So the force on a unit area is called pressure. That is, if you can recall in your physics, that is what we call it. And the more we have this collision on the wall of the container, the more we are having more pressure exerted on the container. That is why I have here more collision will give you higher pressure. I don't know if you get me on that. Now let's also use this kinetic theory of matter to explain temperature. For temperature, in the song I say that the gas temperature is directly proportional to the average kinetic energy of gas particle. This is kinetic theory of gas. Okay, in that place, what I'm trying to tell us that temperature is actually a measure of the average kinetic energy of all the gas particles in the container. So what happens here is that if we increase temperature of gas, the molecules of the gas will gain kinetic energy. The more you increase the temperature, the more the kinetic energy. And you know that the word kinetic means motion. So the more you increase the temperature, the more we have motion energy. So they will move more, they will move faster, they will move speedily. That's what I mean here. So while they are moving speedily, they will have higher energy. So increase in temperature will give us increase in kinetic energy. That is what I am trying to explain here in this kinetic molecular theory of gas. And kinetic molecular theory of gas led us to some people developing laws in order to calculate the changes in pressure, the changes in temperature, and the changes in volume of gases in a container. We have six basic here, although we still have others. There are so many of them, but we have six basics. And in this video, we're only treating four. Boyle's law, Charles law, Gay-Lussac's law combined together as combined gas law. Although we still have another Gay-Lussac's law we are going to treat not now. Avogadro's law and ideal gas law, we are going to look into this ideal gas law. Dalton's law of partial pressure, we are going to treat it in the next class, that is the next video. So for now, we are going to be looking at Boyle's law, Charles law, Gay-Lussac's law. And in that my song, I have Boyle's law and Charles law. How I used to sing it is Boyle's law, Boyle's law. The volume of a given mass of gas. If you watch that, you get it. So let's go with units that we can use in describing this. I want you to know that the word liter or millimeter, the word liter is the same thing as decimeter cube, and the word milliliter is the same thing as centimeter cube. So 1000 milliliter is the same thing as 1 liter. That is to say 1000 centimeter cube is the same thing as 1 dm cube. And for me, I normally tell students, if the unit is actually in dm cube, always convert your centimeter cube to dm cube. I hope you get me on that. Okay, for temperature, we only use Kelvin for temperature. We don't use Celsius. Therefore, if they give you value in Celsius, you need to convert it back to Kelvin. How do we do that? The value they give you in Celsius, let's say it is 0 degrees Celsius. Add 0 to 273, it will give you 273 Kelvin. If it is 1, add 1 to 273, it will give you 274 Kelvin. If it is 2, add 2 to 273, it will give you 275 Kelvin. If it is 7, add 7 to 273, it will give you 280. That is, if it is 17 degrees Celsius, add 17 degrees Celsius to 273, it will give you 290 Kelvin. See, for Kelvin, we don't say degree. We don't say degree there. For pressure, we have atmospheric pressure, we have Pascal, we have torr, we have millimeter of mercury, we also have bar. I want you to know that 1 bar is equal to 1 atm, and this 1 atm is the same thing as 101.3 kilopascal, and this 1 atm is the same thing as 760 millimeter mercury, and this 1 atm is the same thing as 760 torr. So we can make use of any of these, but for our simple calculation, I'm only working with atm and millimeter mercury, even in your exam. But after this term, the next time we are coming over to do on gas law anywhere, we are going to be using all the types of the unit of pressure, but I don't want to confuse us. Let's just focus on atmospheric pressure and millimeter mercury pressure, please. So there is a word we normally see on statement STP. In the song of mole concepts, I said volume of the gas at STP all over molar volume of the gas at STP. That word STP means standard temperature and pressure, and the standard temperature is 273 Kelvin, which is something like 0 degrees Celsius. I need you to know that. And standard pressure is 1 atm, and this 1 atm is the same thing as 760 millimeter mercury. Please get that. So let's start with Boyle's law. If you squeeze a gas sample, you make its volume smaller. For instance, if you see a can and you use your hand and start to squeeze it, what you are applying is pressure. Remember, I told you that a force on area is pressure. You are applying pressure. The more you apply pressure, the more the volume decreases. So there is somebody who brought up this law, Robert Boyle. He says that at constant temperature, the volume of a given mass of gas is inversely proportional to its pressure. And according to that my song, how I put it is Boyle's law, Boyle's law, Boyle's law. The volume of a given mass of gas is inversely proportional to its pressure at constant temperature. That is what I use in that song. So what we have here is that if you want to represent this thing mathematically, we can use it as P is inversely proportional to 1 all over V, or we can use it as V is inversely proportional to 1 all over P. Any of them is correct. Now, if we remove this sign of proportionality, let me use the V rather than the P. So let me have a little clean on this. Let's use V directly proportional to, V inversely proportional to P. So if I remove this sign of equality, proportional sign, we are going to introduce equality sign multiplied with a constant. So we are having here V equal to K times 1 all over P. If we bring this thing down, we are going to have V is equal to K all over P. So we can make K the subject formula where K will become K. Please look at where I'm using my K here. Please bear with me on that. K will become VP. What this VP is implying is that the pressure, the first pressure here and the first pressure here and the first volume, if I increase the pressure to a pressure 2, as you can see here, and if you multiply it with the volume, it will also give you the same thing as you see here. I hope you get me on that. So this is a simple way of representing Boyle's law, and the equation here is actually something you can go with. Well, look at what I wrote here. I said that at constant temperature, the volume of the gas increases as the pressure decreases, and the volume of the gas decreases and the pressure increases because they are inversely related. See what happens here. I want you to know that if we are plotting graph of volume against pressure, this is how it's going to look like. But if you are plotting graph of 1 over P against V or 1 over V against V, we are going to have the graph to move like this. Rather than this curvy, you move a straight line. I want you to grab that. That is why I'm bringing it over for us. So let's look at this diagram here. This diagram is a movable pistol, and they said that the volume is 100 milliliter at 25 degrees Celsius and the volume of B is 50 milliliter at 25 degrees Celsius. Now a container where the volume can change, we can use that. Example of that is syringe. Yes. So what happened here, we had to answer some question. If you look at the temperature are same. That is what we mean by temperature being constant. So look at this question. In which system is the pressure higher? We can know a system that has a higher pressure if we check the volume. So if you look at the volume here is 50 and the volume here is 100. Since the volume here is less, the B is less, so the answer should be B. Okay, so let's go further to a simple Boyle's law question. Please be careful on how I am answering this question. It is very, very crucial for me, and I even gave it some points, say 3 points. So if something like this comes in exam, this is how I'm going to mark it for you. So please, if I were you, look at this question. After watching this video, pause it and see if you can be able to solve this. So what are you going to do first? Solution. Let's read the question. 20 centimeter cube of a gas has a pressure of 800 millimeter mercury. Calculate its new pressure if the volume is increased to 30 centimeter cube. Look over here. 20 centimeter cube of a gas is for volume. 800 millimeter Hg is for pressure. That is the first volume and the first pressure. And if we look at it, say calculate its new pressure. That is that the second pressure is not found. The P2 is not found, but the volume 2 is 30 centimeter cube. So the given, if you are able to write out this given like this for me, you earn half point, which in exam is actually half mark for you in exam. So the initial volume here is 20, final volume is 30, initial pressure is 800, but the final pressure is unknown. So the next thing for you to do to gain another mark is to create the connection between these parameters. Some people call it equation, some people call it formula. So you need to write equation connecting the parameters, which is P1 V1 equal to P2 V2 from Boyle's law. This will give you half point or half mark in exam. I hope you get me on that. So the next thing you're going to do for me is to substitute the values in the equation. Listen, I don't advise students to do change of subject formula in exam for me, because it is actually meant for people that are very very good in mathematics. But for some of us that are not that good in mathematics, just insert the value. That P1 is 800, the V1 is 20, as you can see on the screen. The P2 is 30, is P2, and the V2 is 30. So if you are able to insert this value just like this without you doing the calculation, you have earned another half point. If you calculate half half half, you have gotten 1.5 point, which is approximately 1.5 mark in your exam. You have not even gotten the answer. So if you multiply 800 by 20, you have 16,000, and we are having 30 P2. And if you divide both sides by 30, you will have P2 equals to 533 millimeter mercury. Now the millimeter mercury here is half point, and the 533 is actually 1 point. So even if your calculation you do not get it perfectly and you are able to know that it is millimeter mercury, I personally will give you half mark if such question appears for you. I hope you get me on that. So let's look at Charles' law. Charles' law said that at constant pressure, the volume of a given mass of gas is directly proportional to the temperature of the gas. In that song, I used like in Charles' law, Charles' law, Charles' law. The volume of a given mass of gas is directly proportional to its temperature at constant pressure. Any of them you use is correct. Now, if you look at the diagram, this is volume against temperature. The graph, if you look at it, you will see that it's a straight line graph, but that of pressure is not a straight line graph. I hope you get me on that. So what I want you to know that this V1 all over T1 equals to V2 all over T2 is actually gotten from just a simple thing here. If we increase the temperature of a gas, if you increase the temperature of a gas, what we are going to have is that the speed of the gas particle will start to collide more often, as we said already, because they have gained more kinetic energy, and they will be forced to be hitting the wall of their container. And when they're hitting the wall of their container, if it is a flexible container, the container will start to expand, just as you see this balloon over there. That is why I use balloon to put up on the right hand top right hand of the screen. So according to Charles' law, we believe that V is directly proportional to T. If you introduce sign of equality, we will have it as V equal to K T. Then if we make K the subject formula, we will have it as K is equal to V all over T. It means that if we have V1 all over T1, that is, if you have the first volume and we have the first temperature, we record it. And if you do it by calculation, it will give us the same value. If we created another temperature and we see the volume, you're going to have it. That is what I mean by V2 all over T2. Remember that the graph is a straight line graph coming out from the origin. So you have to grab that in. So a sample question for Charles' law we are going to work on is at 17 degrees Celsius, a sample of hydrogen gas occupies 140 centimeter cube. What will the volume be at 27 degrees Celsius if the pressure remains constant? Here I'm also giving 3 points. For every question that looks like this, I will leave it for 3 points if I have such question coming out. So I would like you to practice this type of question. Majorly practice the question you have in your example book. Also practice the question you have in your notebook and your printed workbook. It will help you a lot. If you check the questions from your your test, you see that most of them are actually what you did in the class or what you have in the printed work, or even what I gave you people as an assignment. Solution. So given we have initial volume 140, as you can see from there, and final volume is actually what we are being asked to get. What will be the volume? Do you understand me? Okay, initial temperature is the first temperature we see here, 17 degrees Celsius, but we don't use degrees Celsius to work. We work with Kelvin. So we convert 17 degrees Celsius to Kelvin. 17 plus 273 will give us 290 Kelvin. Final temperature, we have final temperature to be 27 degrees Celsius. This is the temperature we are looking for the volume. So we have 27 plus 273 will give us 300. If you're able to write that this parameter, you have gotten half point. So we go connecting parameters. V1 over T1 will give us V2 over T2. If you're able to connect these parameters, you have gotten another half point. So we go for substitution. For substitution, 140 is for the V1 and 290 is for the temperature 1. Then V2 all over 300, you have gotten another half point. You have not even done the calculation. You don't even have the answer, but you have gotten at least 1.5 points. Now, by cross multiplication, because this requires us to do cross multiplication, we are going to have 140 times 300 equals to 290 times V2. So here we can divide both sides by 290. We will have V2 to be 144.8 centimeter cube. And I can actually approximate this value more to 145 centimeter cube. But know that the centimeter cube gives me half point and the value itself calculated gives me 1 point. So I want you to look into Gay-Lussac's law. In Gay-Lussac's law, what we're actually looking at is that if we increase pressure, if we increase temperature, we're also going to increase pressure, because I already told us that when we increase temperature at constant volume, you will notice that the gas particle will get much energy and they will be hitting the wall of their container. The more they have more energy, the more they hit the wall of their container. And hitting the wall of their container is actually the same thing as creating pressure. So the more collision of gas particle on the wall of their container, the more pressure. That is what Gay-Lussac is trying to tell us here, and I hope you understand him. So let's answer this simple question from Gay-Lussac's law. Look at can A and can B. If you look at can A and can B, we are going to answer question from this. Look at here. In which system do the oxygen molecules have the highest average kinetic energy? Temperature. The word temperature is trying to tell you which of them has the highest temperature. If you look at it, we have 400 Kelvin and we have 800 Kelvin. Therefore, the 800 Kelvin is actually the one that answers the question, which is B. And if we look at the second question, they say, in which system will the particles collide with the container walls with the greatest force and the most often? I already told us that if you increase the temperature of a gas, the gas molecule will gain much kinetic energy and will start to move and be hitting at the wall of the container. The more you increase the temperature, the more they are hitting the wall of their container. So B that has the highest temperature will have more force hitting the wall of their container. We go again. The last one, in which system is the pressure higher? The one that is hitting the wall of the container more is higher. So this still go back to B. I hope you get me on that. Now we are going to combine the gas law of Gay-Lussac's law, that of Boyle's law and Charles' law. Majorly, some textbook will tell you it's just a combination of Charles' law and Boyle's law. Yes, it is correct. If we still have it in combination with Gay-Lussac's law of pressure, it is still correct. So I want to have it as this. This is actually coming as a result of V is inversely proportional to T all over P. So if I go, I will have V is equal to K T all over P. So if we make K the subject formula, I'm going to have K equal to V P all over T. This is what gave rise to this value you are about to see now. You remember I told you that the beautiful thing about this is that you can watch this and watch it over again. So when I clean it, you know what is there. So the next thing I want you to see is the formula it forms. So we are going to work with this. Remember that we are working with Kelvin and not degrees Celsius. So a sample question for general gas combined law we are having as at 27 degrees Celsius, 300 centimeter cube of a gas has a pressure of 500. So 27 degrees Celsius is temperature, 300 centimeter cube is volume, and 500 millimeter mercury is pressure. One, all of them are, that is T1, V1, and P1. Calculate the pressure. We are looking for pressure now. Of 200 centimeter cube, we are giving the second volume of the same gas at 127 degrees Celsius. We are also giving the temperature. So we have given to be this, and we have this to be this. Will give you half mark. So if you connect it, it will give you another half mark. If you substitute it, it will give you another half mark. Now look at the reason why I always tell you just do the connection. 500 times 300 all over 300. If you cancel the 300, you remain only 500. 200 over 400. If you cancel, you remain only 1 over P. So that is P over 2. So we are having here 500 equals to half P. And if you multiply both sides by 2, we are going to have 2 times 500. Therefore, the answer gives us 1000 millimeter mercury. The millimeter mercury here is half point, and the 1000 as your value calculated is 1 point. So let's look at ideal gas law. When we are talking about ideal gas law, we are trying to look at the combination of both Avogadro's law, Gay-Lussac's law, Charles' law, and Boyle's law. So we are going to work on this here. So there's something I want you to know, that P here represents the atmospheric pressure, and mostly for standard temperature and pressure, the value is 1. Volume in liters, the actual volume of gas at the volume of gas at STP is 22.4 dm cube. So we are 22.4 liters. That's what you can use here. So if the number of moles for at STP, we normally use 1 mole, so the value here is going to be 1 if we want to get this out. That's what I mean here. And T is the temperature, and this temperature are standard temperature and pressure. The standard temperature is actually 273 Kelvin. So we go with R. You may ask yourself, how did they get the 0.08206 as the value of R? So if you make P to be 1, make V to be 22.4, make N to be 1, and make T to be 273, you can do the calculation and you'll notice that the answer is this. Let's look at the question that has to do with ideal gas law. Ideal gas law example: how many moles of oxygen will occupy a volume of 2.50 liter at 1.208 atm and 25 degrees Celsius? Remember, what we are looking for is mole. So let's look at, they gave us R to be 0.0206. Please, this is 0.0206 value. So we start with what is being given to us. We have here P given to us to be 1.2 atm, and we have V given to us to be 2.5 liter, and we have temperature given to us as 25 degrees Celsius. If we convert it to Kelvin, it will give us 298 Kelvin, and you are going to earn half point for just this alone. So we go again, connect the equation, you have another half point. That is, you have gained 2 points, which is the same thing as 2 marks. So we go again, substitute the value. Remember, I say don't do anything that has to do with change of subject formula. Just insert the values for me. You will earn another half point. So we have here, if you look at this value, this 1.2 times 2.5 will give you 3, and all this value here will give you 24.45 N. If you divide both sides by 24.45 N, we will have our N to be 0.123 moles of oxygen. Thank you very much for watching this video to this extent. Please don't forget to click on that Google form work. But before you do that, watch this video again. If possible, watch it the third time. The Google form question is not a now question. It is a question that you can answer between now and Thursday. So you can make sure you have your time to watch this video up to 3 times before you answer those questions, because the question you're going to see in the objective Google form is going to be very, very corny, and it requires much attention and time. Thank you very much for watching this video. And if you have any question that is bothering you, please don't write to me on my WhatsApp. I will not respond to you. Just direct your question on on the video. I will pick it up and answer you one after the other. Thank you and God bless. Remain blessed.